Good morning, students. I am Meshok sir, working as a science teacher in IMST School Malkangiri. In this video, I am going to explain you what is the difference between mass number and atomic mass. I found many of my students getting confused a lot between mass number and atomic mass. Let's have a look at this. Mass number, it's just a number or it's just a count. For example, just like the total number of students in your class. If I ask you the total number of students in your class, you may answer 40 or 50. You will not tell 40 kg or 40 meter. You will just tell 40. Therefore, there is no unit for mass number. It's just a number or it's just a count. But atomic mass means it's a mass. Therefore, it must have a unit. For example, if I ask you what is the weight of all the students, combined weight of all the students in your class, you may answer 1000 kg or 2000 kg. So therefore there is a unit there. So for atomic mass, the unit is U. Now, if I ask you to calculate the mass number or atomic mass, first of all you should consider the nucleus. Why? Because I will tell you. Consider the mass number. Mass number is nothing but the mass of the nucleons. What do you mean by nucleons? Inside nucleus what will be there? Protons and neutrons. So protons and neutrons are together called as nucleus. Okay, protons and neutrons are together called as nucleons. Now let us have an example. What is the mass number of neon? The mass number formula is number of protons plus number of neutrons. Neon atomic number is 10. Therefore number of proton also 10. And neon's number of neutron is also 10. So 10 plus 10, 20. That's all. Simply 20. It is not 20U or not 20 kg, just 20. So that's why I told, if I ask you to find the mass number or atomic mass, you should consider the nucleus. Now, let's move on to atomic mass. Atomic mass is nothing but the mass of an atom. You should understand one thing, the mass of atom is almost equal to the mass of the nucleus. So you know, in every atom, nucleus will be at the center. You should understand one thing, the mass of the entire atom is almost concentrated in the nucleus. Let me tell one example. You consider a shot put and you should consider that the shot put is the nucleus. Now measure the weight of the shot put, maybe 8 kg. Now cover the shot put with some small thin papers like tissue paper. So the area may be more but the weight will be very less. Now with that paper you measure the shot put. It may be some 10 grams or 15 grams, very less amount more. That's all. So you should relate it to the nucleus of the atom. Just as the shot put, you can compare the shot put with the nucleus. So how the shot put is with the paper, similarly the nucleus is with the orbits. You know the nucleus are surrounded by the orbits and the electrons are revolving around the nucleus in the orbits. Okay, therefore one thing you should understand is the mass of the atom is almost equal to the nucleus because the orbits and the electrons are very less in mass. Therefore their mass can be neglected because they are very negligible. So mass of the atom is equal to the mass of the nucleus. So inside nucleus what will be there? Inside nucleus protons and neutrons will be there. Therefore mass of the nucleus is equal to mass of protons plus mass of neutrons. Now compare this. Mass number is number of protons plus number of neutrons and atomic mass is mass of proton plus mass of neutron. And you should understand one thing, the mass number and atomic mass are most of the time they are same in value. Value wise they are same, but mass number has no unit, atomic mass has the unit U. Let me tell one example. If we consider oxygen atomic number is, mass number of oxygen is 16, but the atomic mass of oxygen is 16U. Numerically they are same, but one has unit while other has no unit. So how they are numerically same? Because one is a count, as I told you, one is a count and another one is a mass. Then how they have same value means, here is the answer. Because the mass of one proton, the mass of one proton is approximately equal to 1 U. Similarly, mass of one neutron is also approximately equal to 1 U. Therefore, if there are 16 proton, then they will constitute a mass of 16 U. That is why the mass number and atomic mass are same by value. Let us take the example. Another example, chlorine. Sorry, let us not take chlorine. So let us take neon. So neon, the mass number of neon is given by number of neutron, that is 10, plus number of protons. So 10 plus 10 is 20. Similarly, the atomic mass is given by mass of proton plus mass of neutron. There are 10 proton, therefore 10 U, plus there are 10 neutron, therefore another 10 U. So 10 U plus 10 U, 20 U. Okay. Now let me tell one thing. So why I didn't took chlorine for this? Because for chlorine alone, the mass number is 35, but the atomic mass is 35.5. I will tell you in the next video why there is a difference in this. But now in this video, let us concentrate only about the mass number and atomic mass. I hope now you understood what is the difference between mass number and atomic mass and how to calculate the mass number and atomic mass. It's simple. First calculate the mass number and write U along with the mass number. For example, if you consider sodium Na, atomic number is 11, that is number of proton is 11 and the number of neutron is 12. Therefore, the mass number is 11 plus 12, that is 23. The mass number of sodium is 23, you easily calculated. Then what is the atomic mass? With that 23, you just put one U, that is 23 U. That will give the atomic mass. Hope you understood the relationship and the difference between atomic mass and mass number. I will meet you in the next video. Thank you.